absolute value of complex numbers. I'm going to divide this phrase to two terms. First is absolute value, and the second one is the complex numbers. So first, I'm going to go to the absolute values. We have, by definition, absolute values is the distance from 0 to a number on the number line. So, for example, absolute value of 2 is going to be equal to the distance from 0 to 2, which is equal to 2. And the absolute value of negative 4, right here, is the distance from 0 to negative 4. So that distance is equal to 4. Alright, so the second one is the complex number. By definition, complex number is a sum of a real number and an imaginary number written in form a plus bi. So example, we have 6 plus 3i. So we have the x-axis is a real number and the y-axis is an imaginary number. So 6 plus 3i, 6 on the real number and 3i to the up because it's positive to the y-axis on the imaginary number. So we have 6 plus 3i. Another example you can see is 3 minus 2i. So 3 on the x-axis, the real number, and negative 2i on the imaginary number, on the negative. So this point represents the 3 minus 2i. You compile two terms, you're going to have the absolute value of complex numbers. So you see on the complex numbers 2 points. So what is the absolute value of 6 plus 3i? It is going to be the distance from 0 to that point, 6 plus 3i. And this distance is going to be equal square root of 6 squared plus 3 squared. And they're going to be equal to 3 square root of 5. Similarly, if you do with this point over here, distance from 0 to 3 minus 2i, you're going to have the absolute value of 3 minus 2i is going to be equal to the distance, and that's going to be equal to square root of negative 2 squared plus 3 squared, and they are going to equal to square root of 13. That is how we're going to calculate the absolute value of complex numbers.